Hi everyone, I am Manan, a co-founder at Intugle. One of the biggest challenges in today's world while building Gen AI applications is the data challenge. And that's where we've seen data teams spend majority of their time, around 70 to 80% of their time, just preparing the data. And that's where our platform comes in. With Intugle, you can transform fragmented datasets into a connected semantic intelligence, making data more accessible and useful for building Gen AI use cases. In this video, I will show you how it really works. So it starts off with connecting your data to our platform, and that's where we built a bunch of data connectors using which you can connect to any kind of a data system. Once you've established connections with your data, the next part is to bring in all of this data on a canvas. So here, as you can see, I have a bunch of data tables which I can bring it on the canvas. And now if you closely observe, this is how typically a data ecosystem would look like in any client organization, wherein they have bunch of data tables that are sitting in silos. Now the first step is to classify all of this data under respective data domains, and that's where we have our first AI agent, which is a domain classification agent, which wherein you go ahead and define your data domains, and then you classify a bunch of sample tables under each one of these domains. And then once you execute the AI agent, it automatically classifies remaining data tables under respective domains. Let's see how it really works. So now you can see all the data tables that are tagged under respective domains. For example, I have my returns service request tables tagged under support and services. I have my install base orders tagged under sales and orders. I have my product hierarchy, product features under product master, and that is how it has tagged all the data assets under respective domains. Now, one thing that I would like to highlight here before we move forward is that when it comes to visualizing your data ecosystem, there are three levels of hierarchy that you can notice here. The first level of hierarchy is the data domains, for example, support and services, product master, sales and orders, customer master, etc. There's a second level of hierarchy that you can see here, which is the data tables tagged under each one of these domains. For example, I have install base, orders, opportunity tagged under sales and orders. I have customer hierarchy, customer demographics tagged under customer masters, so on and so forth. And then there is a third level of hierarchy, which is the attributes or the columns that are tagged under each one of these tables. So that's how we create a logical grouping of data assets. Once you have done that, let's imagine a use case now. Let's say if you have to build a customer 360 kind of a view, wherein you want to tap into customer interactions across different stages of the life cycle of a customer, right? Now, for you to build this kind of a view, you would need to understand the relationships between your data. For example, how is my marketing data related to sales data? How is my sales data related to supply chain? How is supply chain related to support and services? So on and so forth. Now here, that's where we have a second AI agent, which once you execute will automatically identify the relationships between your data. So as you can see, all the relationships that tells how each one of my data tables are connected, right? So now let's say, for example, if I want to know how are my customers related to respective domains. So once you click on this, it tells you how is the customer ID related to sales and orders, how it is related to support and services, how it is related to supply chain. Similarly, for the products as well, you can see how is your products data related to support and services, marketing, sales and orders, and supply chain. And that's how you can identify the relationships between your data. Once you have done that, the next question that you might have is how accurate are these relationships, right? So here, let's say in this case, if I have to join my install base table with customers table, it says party ID is my primary key and C underscore ID is my foreign key. So now if I right click on any of these relationship and click on inspect relationship, here it gives me a complete detail saying that if I join both of these tables, what is the kind of mapping or the intersection that I'm getting between these two tables. And that's how you can take a call on the accuracy of these relationships. Once you have done that, the last part is the business glossary. So here again, what we have seen is that the way nomenclature of table names, column names are defined in an enterprise setup, they are very technical in nature and may not be very intuitive for a business guy to understand what does this column or a table really mean. So here again, just on a click of a button, the platform automatically generates the detailed definitions of your data along with the alternate business tags. So what are these business tags? So for example, let's say a customer can be called as a party. It can also be called as an account or a contact. So it creates those alternate tags so that whenever a business user is exploring the data, he gets a very seamless experience. So yeah, once you've built this intelligent semantic layer, the next part is to go ahead and publish this, where then the users can come utilize this semantic intelligence layer to build unified data products on top of it. That's the second module of the platform. Now, once the user lands on this, so he can first of all that you see, he can visualize the entire data ecosystem in terms of what all data is available for him to build a use case. And then let's say if he wants to understand any of these data points, he can just right click. So here it gives him complete details, a complete profile of the data in terms of what is the data type, what is the definition of the data, what are the tags, and how does the health of the data really look like. So now let's imagine a use case. Let's say if you have to build a product lifecycle management kind of a use case, or let's say you have to build a customer 360 kind of a use case, wherein again you want to bring in a bunch of customer attributes across different tables, right? So in a traditional scenario or a traditional approach, you would typically deploy a team of, let's say, 15 to 20 data analysts, data engineers, data architects who specializes in identifying customer attributes across your data ecosystem, building data pipelines, transformation jobs to bring all of that data together and build a query, right? So in any optimistic scenario, it would anywhere take between 45 to 50 days for any client organization to build this kind of a view, right? Now, as opposed to that approach, just imagine a user directly lands on this intelligent semantic layer, and he can just simply pick and choose any data attribute that he requires for his analysis. He can just right click and add the attribute to his data cart, right? So across this universe, you can just keep on adding data points to your cart. Now, to make things even more accessible, what a users, if they are not very familiar with the exact nomenclature of the data, they can just do semantic search. Now, let's say if I want transactions information, I can provide that as part of my semantic search, and it will redirect the user to actual column name. So I can just right click and keep on adding the attributes to my cart without even worrying about how will they come together, what kind of joins will be performed, what kind of a query will be built in the backend. So I can, without even worrying about any of those complications, I can just simply go ahead and keep on adding the different attributes to my cart. Now, let's say in this case, I've already shortlisted these customer attributes that are coming in from different tables, different domains. I can quickly review my data cart. And then as soon as I click on next, right? So here you can see that it gives from that entire universe of the knowledge graph, it creates a subset graph based on the selections that the user has made and automatically generates a navigation path in terms of how all of these attributes will come together to form a unified view. There's an automated query that gets generated, which gets executed to give you a one single unified view of your customers, wherein you can see all of these customer attributes coming in from different data sources, different tables in a one single view within a span of few minutes. So now this whole functionality that I talked about, wherein a business user or a power user, I would say, would come shortlist data attributes to build his unified view, is still relevant for a persona who is a power user and he understands the intricacies of the data, right? But now let's imagine if there's a user who doesn't understand the data and still wants to derive insights from the data. So for them, we have this conversational AI interface wherein users can come ask questions in their own language. So now let's say if I want to see who are my high value customers, I can simply give this requirement in natural language. And then the platform goes through series of steps to translate this business requirement into an executable query, which gets executed to give you a response. So that's how business users can come and start asking questions in their own language to generate insights instantaneously. So that's all from my side. Thank you.